Okay, so looking at this first one, what is the degree even or odd? Remember, the degree is the highest exponent, so that's a 3, right? So this is an odd degree, which tells me that I'm going to have opposite in behaviors. I'm just going to write opposite so we can remember that. Okay, so the number in front, go ahead and make a little mini sketch. Okay. So is this a positive or a negative number in front of this x cubed? Positive. And remember, I'm not looking at this. This is what tells me all of my answers because it's the highest exponent. Because it's positive, it's going to go up on the right. And the left side, because it's odd, is going to do the opposite. It is going to go down. So what you're going to write, because remember that when it says x approaches negative infinity, this means left side. And x approaches positive is the right side. So on the left side, it is going down. So I'm going to put a negative infinity there. And on the right side, it is going up. So that would be a positive infinity. The maximum number of zeros is your degree. And because this is a third degree, the maximum would be 3 x-intercepts. The minimum, is that going to be 1 or 0? Who remembers from yesterday? What would you say, Jewel? 1. Yep, it would be 1 because it's odd. Odd degrees have to have at least 1. For my second function, again, I'm looking at my highest degree. That would be negative 3x to the 4th. So is this an even or an odd function? Even. So my behaviors are going to be the same. And because this is a negative 3, it is going to go down on the right. And the left side is going to do the same thing. So both sides go down. The maximum for this one is 4. And the minimum is 0. That's just a quick recap of what we covered yesterday. Any questions about that? Go ahead and go to page 269. We're going to answer some questions about the graph. So I'm going to go ahead and add my arrows. So are the arrows going in the same or opposite direction? Opposite. So that means this is a what function? Even or odd? Odd. Let's circle odd. We know it's odd because we have opposite arrows. When you're looking at a graph, to determine if the leading coefficient is positive or negative, focus on the right arrow. So the right arrow is this one. What is that one doing? Is it going up or down? It's going down, so that means this is a negative. The zeros are your x-intercepts. And you have 3. So let's write these as ordered pairs. Where are those 3 points that I just put on the graph? Those are your zeros. So the first one is that -3 or -4? So 0, -4, or -4, 0? How do you write it? What comes first? Yeah, we're going to put the -4 first. My picture is pretty blurry here. I don't know if it's blurry in your book. So this is -4. And this one looks like it's -1. Is that correct? Okay. So -1, 0. And then what about this last one? Where is that point at? 2. So now let's write our equation. When you write your equation, every 0 gets a parentheses. So every 0 or every x-intercept has its own parentheses. So I have f of x equals, I'm going to make 3 parentheses. 1, 2, 3. So if I have an x-intercept at -4, the factor is going to be the opposite. So in the parentheses, I'm going to flip the sign and put an x plus 4. For my second x-intercept, that's at -1. I'm going to flip the sign and put an x plus 1. And what do you think I'm going to put in my last parentheses? Because that's a positive 2, x minus 2. And because this one starts, this is a negative, we have to put a negative sign in front. Anytime the right side goes down, we have to start it off with a negative sign. And that would be my equation in factor form. So let's look at question number 2. And I'm not sure why that the graphs never have arrows. So I'm going to add the arrows. All right. What do you think your degree is? Even or odd? What do you think? Even, I agree. Because notice how they're both going down. So this is an even. Remember, the right side determines if it's positive or negative. It's easier to tell for an even degree if it's positive or negative, because if they're both going down, then that means it's obviously negative. So this is a negative. Your domain will always be all real numbers for your functions. For your range, you're looking for your lowest point. Because it's going down, the lowest point is -infinity. And the highest y value is right here. What is that number right here? What is that highest y value? 4. So that would be your range. Range is always lowest to the highest. Your lowest to the highest. If it's going down forever, the lowest is -infinity. Both sides are going down, so your end behavior for the left and right would be f of x approaches -infinity. We have 2 zeros, one at -1 and another one at +3. So I'm going to write my intercepts as negative 1, 0, positive 3, 0. And then we're going to flip our signs. We only have 2 x-intercepts, so we only need 2 parentheses. And then front, because it's going down, we put a negative. And that is your equation. So first thing first, what do you think your degree is going to be for this one? Is this even or odd? Odd. Good, because both, they're going opposite directions. Odd, opposite. That's how I remember that. What is it doing on the right? Because remember, this is the left. This is the right. It's going up, so that means it's a positive leading coefficient. So we're going to circle that. Now, write this in your notes somewhere, because every odd degree, if it's an odd degree, your domain and range is all real numbers. Every single odd degree function has the same domain and range. So if you see a graph and the arrows are going opposite directions, you automatically should know your domain and range. It's only when it's even that we have to look at it closely for the range. All right, so on the left side, because this is left, this is right, on the left side it's going down, so f of x is approaching negative infinity. And on the right side, it's going up. For my zeros, I have 2. One is at negative 1 and one is at positive 3. And this one here, for my equation, f of x equals, I have an x plus 1 and an x minus 3. Okay, so when we look at this, now we have to look, we're going to add one more thing to it. Notice that when it touches the graph at x equals 3, it doesn't go through it. What does this look like? What kind of graph does this remind you of? That shape. What kind of function looks like that when you graph it? A parabola. It's a parabola. So what that tells me is on this factor right here, we have to put a square on it. You have to square that one. Because it bounces, it doesn't go through. So if it bounces, then we have to square the factor. Because now, if we didn't put that 2, this factor has an exponent of 1. 1 plus 2 is 3. We have that odd degree. Do I need to add a negative sign in the front? Is this a negative function? What is it doing on the right? Is it going down? It's positive. So you don't have to put the plus sign. You can. I'm going to put it just because we're learning. But you only have to put it when it's a negative. But this is a positive function. All right, so let's go ahead and do a couple sketches real quick. Go to page 271. So I'm going to add up my exponents. If you don't see an exponent, the exponent is 1. So there's a 1 here and a 1 here. So when I add that together, I get 2. My degree is 2. Because you add the exponents to get your degree. So we're looking at number 2 on page 271. Yeah, because of time, we have to skip around a little bit. So page 271, number 2. Sorry about that. So there's a 1. There's an invisible 1 right here. If you don't see an exponent, that means that it is 1. When I add it, I get 2. Is 2 even or odd? Even. Do you think this is a positive or negative function? Look at the very, very front. You see that minus sign in front of that x plus 2? So this right here tells me this is a negative function. This is negative. Okay, so let's go ahead and find our x-intercepts. So to find our x-intercepts, we're going to set both factors equal to 0. Go ahead and solve both of our equations and write them both as ordered pairs. So take the x plus 2, set that equal to 0, and then take x minus 6 and set that equal to 0. And we're only going to sketch it. We're not going to make a T-chart and do the y times a plus k. We're just going to do a sketch, okay? So when we do our sketch, put your point. So we need to put a point at -2 on the x-axis, because when you solve this for x, you get -2. So put a point at -2, and then put a point at 6. So do you think this is going, because we know it's even, so because it's even, it's either going to be up, up, or down, down. So do we think this is going to be a smile parabola, or is this going to be a frown parabola? Which one is it going to be? It's going to be a frown. So all I want you to do is just sketch it. And because both sides are going down, my end behavior is negative infinity for both. So for number 3, we have to factor it first. So the first thing we're going to do is take out our GCF, which would be 4. So let's divide both of these terms by 4. So this is factoring. We haven't had to factor for a while. Does anyone remember how to factor x squared minus 25? It's a special case. You need two numbers that multiply to be -25, but add to 0. They're opposite numbers, because 25 is a perfect square. Yep, -5 and +5. So this is my factored form. My degree is my highest exponent, which is 2, and 2 is an even number. Is my leading coefficient positive or negative? Positive. There's a +4. Okay, so now we're going to find our x-intercepts. We're taking only our parentheses, set both of those equal to 0, and solve them both to get your two x-intercepts. So when you solve it, you should get x equals -5 and x equals +5. So I have two x-intercepts. Let's go ahead and put those 2 points on the graph. Put a point at -5 and +5. So we know that it's a smile because it's a parabola. Is this a smile or a frown? Smile, I meant to say. We know the arrows go in the same direction. So because it's positive, this one is a smile. So it's going to look something like this. It's not the exact graph, but the main thing I'm looking for are your x-intercepts and the arrows. Are the arrows going in the right direction? And because both sides are going up, then that means that we have positive infinity for both of our end behaviors. And our last question for today is question number 4. So let's go to page 272. Oops. Okay, so let's go ahead and factor it. So my GCF for this one is x squared. I can divide both of these by x squared. So x squared is on the outside, and x minus 4 is left on the inside. So my factor form would be f of x equals x squared times x minus 4. So all we can do for this one is take out our GCF. Our greatest common factor. So what is the degree for this function? Not 2. So look at the original equation before we start factoring things out. The highest exponent was a 3. It's a third degree function. And then 3 is an odd number. When you're looking at factor form, remember if you don't see a power as a 1, 2 plus 1 is 3. So this is a third degree function. Is this a positive or a negative function? It's positive. So my x-intercepts, I'm going to set both of my factors equal to 0. So you have x squared equals 0, and you have x minus 4 equals 0. Well, what is the square root of 0? 0. So that means that x equals 0 is one of my intercepts. So 0, 0 is one of my intercepts. And for my second one, I need to add the 4. So x equals 4 is my second intercept. So go ahead and put 2 points. One at 0, 0. And one at 4, 0. Okay, so because this is a positive function, off this 0, I want you to put an up arrow. It's going to go up. And then what do you think it's going to do off this one? Is it going to go up or is it going to go down? Down. So remember, whenever it's an x squared, because this one is an x squared, it is going to bounce. So it doesn't go through at the 0. It comes up, hits the 0, bounces back down, makes a U-turn, and then goes through the 4. So it's going to go up, hit the 0, bounce back down, make a U-turn, and go back up through the 4. That is what it's going to look like. That's a sketch. And in this function, the left arrow is going down, the right arrow is going up. Have a great Thanksgiving break. When we come back, we will have 2 weeks and then we'll be finished.